All right, these notes are on our next transformation after translation, which is on reflections. So we talked very briefly that reflections are a mirror image along some type of line. Before we get to the front side, I like for you to turn your paper over to the back side. There's nothing on the back side, but we're gonna draw a couple of things here. I like for you to draw. We're gonna draw 3 lines. I'm gonna draw my first line here, and I'm gonna put a 3. And when you draw this 3, I want you to draw like the flat top of the 3, and then that curved kind of bottom part. We're gonna draw that with the vertical line. We're also going to draw a 3 right here. Actually, let's do this. Let's draw the line right here and the 3 under. And then finally, we're going to draw a diagonal line. And let's make the 3 go right here. Okay. I'm going to change my color for this, but I want you to see... Right, we have a bunch of the same pre-image, 3s. And based on the line of reflection, our image is going to be slightly different. So if we look at this first one right over here, how does that look like if I reflected about this line? Okay, we're still going to have the 3 be at the same height, and we're going to have that flat top. But it's going to be backwards. It's going to be a backwards 3. So it's going to come from this way. Oops. And then curve the other way like that. So that's a mirror image. Now, if I take this, right, we get somewhat the same of the pre-image. The orientation has changed. Instead of that 3 facing the left, it's now facing the right. All right, let's move on to the next one. We're reflecting this 3 along a horizontal line. So that flat top here, we're still going to have that flat top. It's pretty close to the line. It's slightly below, so we're going to have this horizontal line slightly above. And then we can see like the nose of this 3 goes up, and then it curves kind of the other way. Yeah, I could probably do a better job drawing that, but you get the idea. It doesn't have to be perfect. But we can see, right, this 3, right, its orientation has definitely changed from this other 3 that we drew on the first image. And then finally, we have this diagonal line. This diagonal line is kind of hardest one to notice. But since the flat part of this is pretty close, we're going to have this be the beginning part of that. It was a horizontal line. Since we're reflecting along a diagonal line, it should look like this. So like this, then coming down diagonally, and then rounding out. This is a diagonal. Or sorry, this is a reflection along a diagonal line. Okay, we're going to see reflections of each one of these types for pre-algebra. But anyways, I just wanted to give you kind of this foundational like understanding of what a reflection should look like on a 2-dimensional plane, and that being our paper. All right, let's go back to the front side. Okay, so what is some characteristics of a reflection? All reflections are congruent. They're the same shape, same size. They might change where they're facing, but overall, this is the same figures. And then another thing is the pre-image and the image are equidistant to the line of reflection. So equidistant means equal distance. Yeah, so it's the same amount of space, right? As you notice, like when you look in the mirror, when you look at the mirror from, let's say, a couple of feet back, you're going to seem a couple of feet back in the reflection that you see. When you put your face right up against the mirror, your face visually to yourself looks, from your point of view, looks a lot closer. Like if you put your nose up against the mirror. So we're just saying it should look just about the same size. Okay. We'll get to these parts soon, but actually I want to reflect these items first before we start putting the descriptions. Now this first one will be reflecting about the y-axis. So what I'd like for you to do with your pencil, if you have another utensil, you're welcome to use that. I want you to trace our line of reflection, which is the y-axis. I know this is the y-axis because it says y right here. Now we're going to reflect all the points, all 3 points here. We'll just label them. I'll put A, B, and C. Okay, let's start with A. A is the point 3, 4. So we know to begin at the origin. And we're going to go 3 to the right and 4 up. So 1, 2, 3, 1, 2, 3, 4. Right, this is A. For A prime, put A prime here. It's going to be equal distance to this line of reflection. As we can see, right, this line is 3 units away from that point. Or vice versa, the point is 3 units away. So it's 3 units to the right. So to graph A prime, you're going to go 3 units to the left of where it would meet that line. So right here. Okay, let's go ahead and graph that in. A prime. Now let's go ahead and write the point of this as well. This is an important thing to notice. Graphing this ordered pair, we would first go left and then up. So we would go 3 left, which is -3. And then we would go 4 up. It still has the same height, so +4. Okay, let's go and move on to the next one. I'll put this in blue. So B will be in blue. Let's go ahead and graph -1, +5. So -1 is 1 to the left. +5 is 5 up. So 1, 2, 3, 4, 5 right there. This is where B is. So since this is 1 to the left of the line, that means B prime will be 1 to the right of this line. So that is going to be right here. This is B prime. All right, so let's go ahead and put B prime. And that is, from the origin, we go 1 to the right, 5 up. So that's +1, +5. All right, and then finally, we'll put this in green. For C, 2, -1. So that is 2 to the right, and -1 is 1 down. All right, so right here, we're going to go C. And the same exercise, we're going to figure out, right, what is the same distance? This is 2 units to the right from the line. So we're going to go 2 units to the left of this line. So this, same height, this is C prime. Okay, and C prime is, it is 2 left, 1 down. So 2 left meaning it's -2. 1 down is -1. So -1, -2. Or sorry, -2, -1. Switch that. Okay. Now we have some things that we can notice. First thing you can notice, this part you don't have to draw. But I want you to notice that when we draw, when we connect our pre-image and our image, so I'm gonna connect that for all of them. These lines are always perpendicular to our line of reflection, meaning that it forms a right angle with that red line. It's kind of like an L or a T, right? So that's always a property that happens, that the pre-image and the image is always perpendicular to the line of reflection. Now let's go to notice some things though. I'm gonna put this in red. Let's notice some things with the X values. Okay. So I want you to look at these X values and what do you notice? Are they the same? Are they different? Are they right? Are they increasing, decreasing, whatever? Okay. Now hopefully we notice that from the pre-image to the image, they're all the same number, but they're a different sign. They're the opposite sign. As you can see here, we had a +3. Now we have a -3. We had a -1. Well, what's the opposite of a -1? It's a positive 1. And then we had a positive 2, now it's a negative 2. Okay, so the property here is that when we reflect about the y-axis, the x changes the sign. So let's go and write that here. So for the y-axis, a reflection changes the x value. So what we're going to put here in the box, for the x, this would be negative x. Now negative x doesn't mean make whatever the x is, it has to be negative. No, negative x means whatever x is, you make it the opposite. So that's what that means. And we figured that out by graphing. And then lastly, let's go and talk about the y values here. Okay. So from the first one, we have positive 4 stays positive 4. Positive 5 stays positive 5, and the same thing with our negative 1s. So when we reflect about the y-axis, the y's actually don't change. The y's are exactly the same. So how we had y here, I'm just going to have y here as well. Okay, so lastly here, when you reflect about the y-axis, you change the other variable. The x changes. So I could have used the graph, but I didn't need to. I could have just looked at the points. I could have said, this is going to be opposite. It'll be negative 3, positive 4. We see that right there. This will be opposite. This will be positive 1, positive 5. I see that right there. And this is going to be negative 2, negative 1. We see that for the last one. So we're using our graphing on the coordinate plane to help us determine what is the rule for reflection. All right. Anyways, let's go and move on to the next one. This is slightly different. Now we're reflecting about the x-axis. So let's highlight the x-axis here. Okay, we're going to go a little bit faster. The points 3, negative 5. So this is 3 right, 5 down. Right here. We'll label this A. So I'm looking at comparing this point to that line. In this case, it's instead of left or right, it's below. This is 5 below that line. So I'm going to graph this 5 above that line. That's where the reflection belongs. So that is right here. Same vertical line there. It's not shifting at all, but this is where A prime is. Okay, this will be 3 to the right and 5 up. So that coordinate is 3, 5. So we're going to put A prime, positive 3, positive 5. Next one, negative 4, negative 2. So that is 4 left and 2 down. We'll put B. Since this is 2 below the line, that means when I reflect it, it'll be 2 above the line. All right, so that's B prime. That is the coordinate negative 4, positive 2. And hopefully you can see some differences that are happening right there. And the last one, 0, 4. 0, 4. Actually, you know what? For 0, 4, I'm going to change this. If you can also cross this off for C, let's make this 4, 0. The reason is I just want you to notice something that we haven't seen yet. Is 4, 0 is just 4 to the right and 0 up and down. This is C. Now I want you to ask yourself, that point, how far is that away from the x-axis? How far is that away from that red line? It's on the line. So our C prime will also be, I'll change the color here, will also be on the line as well. So C is on the same point as C prime. So it's still 4, 0. Now I want you to note that, right? When you look at the mirror and your nose is on the mirror, when you look kind of like at your nose, it looks like your nose is at the same point in the mirror as your nose that's, touching the mirror. So that's exactly what we have, right? Reflections are always the same distance from the line. If it's on the line, then it'll remain on the line. Okay. Anyways, So what can we say about reflections about the x-axis? Let's look at the x values here. Did the x values change? No, they're the same. Did the y values change? All right, can't really tell from the 0 here, but it did, right? We had -5, now it's +5. We had -2, now it's +2. And 0 is neither positive nor negative. So a reflection changes the y value. So when we reflect about the x-axis, the x value still stays the same, but the y value, we're going to put a -y. And one more time, that does not mean make y a negative. It means make y the opposite sign. Positives become negatives and vice versa. Okay, let's go to the last one here. And that is reflecting about the line y equal to x. Now that is a diagonal line here. It goes from the origin and it's perfectly diagonal to the corners of the grid. Now the reason that this is y0 is because if you graph any point that's on here, like this point here, that's the point 4, 4. If you graph this point, that's the point 1, 1. That's where the x and the y are equal. Okay. Anyways, we're not going to leave these points though. So I'm going to have to help us with this because this one's generally the hardest one. 5, -2. So this will be 5 to the right and 2 down, right here. Okay. Now to graph this reflected will be right over here. And that is -2, 5. Now we can tell that this is a reflection because if I connect these two, you don't have to connect this, but I will. You can see how it runs perpendicular at a right angle to that line of reflection. Okay, so that is, and also this line to the left or top of it is the same distance as this line to the bottom or right of that line. Okay, well, let's go to 2 more. -3, 0, right here. Actually, I should probably put A's. I'll put A and A prime. This reflected will be right here. So we'll call this B, whoops, and this is B prime. If you connect that, those are two straight lines. So that is the point 0, -3. And then finally, let's erase that. 6, 2. So that is 2 right and 6 up right here. We'll call this C. This is the same if we're to reflect it. The reflection, the image would go to right over here. This is where C prime would be. And that is, so 6, 2. Now, the reason that I know this is because there's a special rule when you reflect about the line y equal to x. If you look at the pattern that we have here, let's look at this and let's look at this. Quite a bit has changed. Now think about what is changing though. Okay, the thing that's changing here is the position of x and y. What was in the first position is in the second position. So see how we had 5 in the front? Now 5 is going second. See how we had -2 second? Now it's in the first position. So when you reflect about the line y equal to x, a reflection switches x and y. So instead of x comma y, what should happen? It's actually y comma x. All right, anyways, we're going to leave it at that. You're going to get to some practice on Map Accelerator / Khan Academy for reflecting points and reflecting shapes.